Hello, this is Mrs. Plenda here to talk to you today about factoring polynomials. Now, last week we talked about multiplying, and factoring is the inverse process from multiplying. So we're going to be reversing the steps that we learned last week. And our first step for doing this is finding our greatest common factor. You've done this before, especially when talking about fractions and adding and multiplying and pulling numbers apart. I'm sure earlier in school. So we're going to do the same thing. So for example, if I'm looking for the greatest common factor of 15 and 25, well, I need to know all the factors of 15, which means all the numbers that multiply to 15. So I've got 1 and 15. I've got 3 and 5, and for 15, that's it. So then let's take a look at 25. All the numbers that multiply to 25. Well, I've got 1 and 25. You're always going to have 1 in the number itself. And I've got 5 and 5. So taking a look at all those numbers that multiply to 15 and 25, which one is the biggest one they have in common? There it is right there, number 5. So our greatest common factor for 15 and 25 will be 5. Okay, so this process that you guys have learned before, we're doing again. There are still numbers on our monomials and our polynomials, and so we need to be able to find that greatest common factor for them. So let's take a look at our next example, 16 and 48. So numbers that multiply to 16, of course, we've got 1 and 16. We've got 2 and 8. We've got 3 and 6, and 4 and 4. Let's take a look at 48. All right, for 48, of course, we have 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. There we go. So now I am looking for the greatest factor that they both have in common. What is the largest number I see in that list in both 16 and 48? Well, it's going to be 16. That's our largest number that they have in common. So our greatest common factor for 16 and 48 is in fact 16. And that's one thing you can always check to see if we're looking for the greatest common factor for two numbers. Check and see if the smaller of those numbers will go evenly into the bigger number, because if that's your greatest common factor, it's a much quicker process than going through and listing all the factors for each number. Now, since this is algebra, we got to add some letters. You know how it goes. So now instead of just 18, I have 18x squared. So I can break that apart in just the 18 and just the x squared. So still thinking about all my factors for 18, 1 and 18, 2 and 9, 3 and 6, and x squared just means x times x. Okay. Then let's think about our 27x cubed. So if I think about just the 27 part and all the factors that I've got there, I've got 1 and 27, 3 and 9, and that's it. So then for x cubed is just x times x times x. So when we're looking for that greatest common factor, for the number parts, we're still looking for the greatest number that they have in common. And for the letter part, now we are looking for the greatest number of letters that they have in common. So looking at my letters, I see I have 2 x's here, and I've got at least 2 x's here. So guess what? On our greatest common factor, I'm going to need 2 x's, or x squared. Okay, and one thing you may notice about this, once we figured out how many x's they had multiplying in common, we can see that that exponent is the smaller exponent that I see on the two monomial terms that I'm looking at here. And that's always going to be the case. Your greatest common factor for your letters is going to be the smallest of the exponents that you see. Okay, that's the way that it works out, because they have to have it in common. So let's take a look at our second example and do the same thing again, because now I've got some extra letters to think about. So looking at 24, I've got 1 and 24, 2 and 12, 3 and 8, 4 and 6, right? See how knowing those multiples really comes in handy? X is just X. Y squared means we've got 2 Y's. Let's take a look at that second monomial term there. So now I've got 42. Well, 42 has 1 and 42. It's even, so I know it's going to have 2. That's going to be 2 and 21. So then it's going to be 3 and 14. And let's see, not 4, not 5. Oh, we've got 6 and 7. There we go. Meet in the middle there, so we're all good. For the x's, since it's x cubed, that means I've got 3 x's. And then I've got just the 1 y. So let's see how much they have in common. Well, looking at these numbers, I see that I have 6 and 6. So that means my greatest common factor will be 6 for the numbers. Let's take a look at our x's. I've got 1x and 1x in common. So that means I'll have 1x for my greatest common factor. And for my y's, well, I've got 2 in this first spot, but only 1 over on the right under 42. So that means I will only have 1 y in common. It has to be in common, right? Our greatest common factor. I'll only have y for our greatest common factor. Okay, so we can find that greatest common factor for monomials the way that we do for numbers. Okay, now I'm taking a look at our greatest common factors for 9b squared and 14b. All right, well, 9, 1 and 9, 3 and 3. B squared gives me b times b. And 14b, well, 14, 1 and 14, 2 and 7. And for b, well, just b. All right, what do they have in common? Well, when I look at these numbers, what's the only thing they have in common? Just the 1, okay? Of course, all numbers have 1 in common as a greatest common factor, or as a common factor, but it's usually not the greatest common factor. In this case, it is. They don't have any other numbers in common but 1, and that's okay. 1 can be the greatest common factor. And let's take a look at those b's. For b's, I've got 1 here and 1 here in common. So that means just 1b will be my greatest common factor. And that's fine. You might not have any numbers but 1 in common. And it's possible to have numbers in common, but no letters. Let's take a look at this next one. So here, I've got 12x to the 5th. So 12, we've already done 12. So 1 and 12, 2 and 6, 3 and 4. And for x to the 5th, well, how many x's is that? 5, 2, 3, 4, 5. I almost wrote a 5 instead of an x. That's not what we're looking for. 5. Okay, then let's take a look at 30y squared. So for 30, I've got 1 and 30, 2 and 15. 5 and 6. And then for y squared, that just means y times y. So looking at our numbers, it looks like we've got 6 in common. So our greatest common factor so far as the numbers go is 6. What about our letters? Do we have any letters in common? No, we just have y's on the left. Nothing but y's, just nothing but x's over here. Nothing but y's on the right. Those are not in common. So the greatest common factor in this case, just 6. So just the number, no letters in this case, okay? All right, now our next step is to take this greatest common factor and undistribute it. So before we get into that, let's remember what happened when we multiplied, right? When we multiplied, we took that outside monomial and distributed it into the parentheses, right? So then I had 6x cubed plus 10x squared plus 4x, right? We took it from the outside and we distributed it in. So factoring is where we reverse this. I'm going to take what's on the inside, and instead of going in, I'm going to take it and I'm going to pull it back out. Okay, so that's what we're looking to do. We're looking to take that greatest common factor and pull it back out to the front. Okay, so first we need to know what that greatest common factor is. So let's take a look at our first example here. Well, between 5 and 9, are there any common factors? Let's take a look. 5 is 1 and 5. 9 is 1 and 9 and 3 and 3. Those do not have any common factors that are bigger than 1. So our greatest common factor here for the numbers will just be 1. And then how many b's do they have in common? Well, just 1, because there's only 1 b here on that front spot. Okay, so if my greatest common factor is 1b, I need to take that, I need to divide it out of each of these. Okay, so 5 divided by 1 is still 5. And if I take 1b, if b divided by b is just 1, so just no b's left over next to that 5, just 5. And then 9 divided by the 1b will still give us with 9. But I'm looking at b cubed divided by that 1b. Well, if I had started with 3 and I took off 1, how many do I have left? 2. Okay. And so you can see what we have done here is I have taken this greatest common factor and I have pulled it out of the inside. So I took it out of the 5b. I took it out of the 9b cubed, and that's a dividing step. So once I had that out there, then I write what's left inside the parentheses, right? So this is what's left. And I can check to see if this is the right way to do it by multiplying that 1b back into the parentheses. If I multiply this 1b back in, would I get back to where I started? Okay. If we do, then we know that we did it correctly. Okay. So let's take a look at our next example. And we first need that greatest common factor. Okay, between negative 35 and 42, my greatest common factor will be 7 for the numbers. And do we see any letters? Well, I see an X here on the negative 35, but none on the 42. That means they don't have any letters in common. So 7 is the single greatest common factor that we have. So then I take that 7 and I divide it out of the terms on the inside. So negative 35x divided by 7 gives me negative 5x. And 42 divided by 7 gives me 6. There we go, all done. I took that greatest common factor and I pulled it out to the front and divided it out so I knew what was left in the parentheses. Okay, so let's do that one more time. Oh, a couple more times. Again, I've got more monomials here to take a look at, so my greatest common factor would be bigger. Again, always look at your smallest one and see if that will divide evenly out of your other two, right? It does not. 6 doesn't, you can't divide 8 by 6 evenly. So looking at other factors of 6, well, I've got 2 and 3. So which of those will go into both 12 and 8? Just the 2. Okay, so that 2 is going to be our greatest common factor so far as our numbers go. And what about our x's? How many x's do they have in common? Well, what's the least number of x's that I see? That one right there, just that one x. So that means our greatest common factor is 2x. So I'm going to take that 2x to the outside and I'm going to divide it out of each piece on the inside. So 12 divided by 2 gives me 6. And if I started with 4 x's and I divided 1 off, now I've got 3 left. Keep going. I've got 8 divided by 2 gives me 4. I had 2 x's, I divided one off, I've got one left. Last one, negative 6 divided by 2 will give me negative 3. If I had 1x and I already pulled it off, how many x's do I have left? None. Okay, so that's all we have to do. We just divide that greatest common factor off of our polynomial. Okay, well, what happens if I start to have lots of letters? Doesn't matter, ends up being exactly the same thing. What's my greatest common factor? Let's take a look. I see that I have my smallest number is 3, so let's think about that. Does 3 go evenly into 18 and 12? It does. That means that 3 will be our greatest common factor. Okay, so then taking a look at that, how many letters do they have in common? Well, I see A, B here, just A. Uh-oh, that means they don't have B's in common. So how many A's do they have in common? Well, I've got 2, 3, and 1. So we always go with the least number. So it's going to be that 1A. Okay. So since our greatest common factor is 3A, we divide that off each time. 12 divided by 3 leaves me with 4. I had 2 A's here, but I already took one off, so there's just one left. And I didn't touch the B's, they stay the same. Negative 18 divided by 3 gives me negative 6. I had 3 A's to start with. I took one off, so now I've just got A squared left over. And then negative 3 divided by 3 gives me negative 1. I had 1 A here. I took it off, so there's no A's left, just the B. There we go. And that is how we factor polynomials. Now, if you're thinking, I didn't like distributing, I liked the box, I chose the box, guess what? You can do the exact same thing with the box. Let me show you real quick. Here's our first example, same one, so we can see that it comes out exactly the same. When we were multiplying with the box, our product always ended up inside the box. So when we're factoring, since it's the opposite, we start with our product inside the box, and then we're going to work our way out. We work our way out still by finding that greatest common factor. We're going to take that greatest common factor, which we already knew was 1b, and pull it outside. Okay, let me do that in a different color so we've got it distinguished. Right? We take that greatest common factor and we pull it out to the front. And then we still divide, or we think about what multiplied with that 1b to make that 5b on the inside. Well, you'd multiply 5 with 1b to get 5b, and you'd multiply 9b squared with 1b to get 9b cubed. So then there's our answer, 1b, 5b, and because it's positive, plus 9b squared. So yes, you can still do exactly the same process with the box. So if you like the box, we can still do that. It's still going to work out exactly the same. Let's do this one, right? Since it's working backwards, we start with our binomial inside the box. I look for my greatest common factor. Since I see that both of these are negative, I know that they'll have a negative in common, and they're both even, so they've definitely got at least 2. Can I take 4 out of 6? Nope, so it's just going to be 2. And how many x's do they have in common? Well, it's always the least amount, which is x to the 1 there. Okay, and what multiplies with negative 2x to get you to negative 4x squared? Well, that would be 2x. What multiplies with negative 2x to get you to negative 6x? Well, that would just be 3. So there's our answer. Negative 2x times 2x plus 3. Okay, last example. Oh, there's actually 2 more, my bad. So again, start with what we have inside the box. So I've got 36x, 18x squared, and 3. I'm looking for that greatest common factor. Well, let's think about it. Does 3, it's our smallest number, so does 3 go in each of these others? It does. So our greatest common factor will be 3. Will I have any letters in common? Well, I don't have any x's on that 3, so no, they won't have any letters in common. So I'm just dividing the 3 out each step of the way, right? What multiplies with 3 to get 36? Well, what's 36 divided by 3? It's 12. And I got to have an x on there. Okay. 18 divided by 3 gives me 6. Got to have those x's on there. And 3 divided by 3 gives me 1. So 3 on the outside is the greatest common factor. 12x plus 6x squared, because it's positive, plus 1. All right, now last one. This one's got a lot going on, so I'll need a pretty big box. All right. So I've got negative 27x squared y squared, negative 24x cubed y, and negative 27x to the 4th y. Well, I know 24 doesn't go into 27, so what other numbers could they have in common? What other factors? And again, if you're not sure, you can always list these out or use your calculator to help you. Nothing wrong with that. The greatest common factor so far as the numbers go is going to be 3. And because everything was negative, I'm going to make it negative 3. Then I look at how many letters. It's always going to be the least. So let's take a look at those x's. I got 2, 3, and 4. That means x squared is the least we see. Let's take a look at the y's. I've got 2, 1, and 1. That means that the greatest common factor for the y's is just 1, okay? And then we divide that out. Negative 27 divided by 3 is 9. If I have 2x squared and I've already got x squared, there's no x squareds to multiply. And if I have y squared and 1y here, I just need one more, so they'll multiply back in properly. Next one, negative 24 divided by negative 3 is 8. I need 3 x's. I've already got 2, so I just need one more. I've got one y. I already have a y, so I don't need one up top. Last one, negative 27 divided by negative 3 gives me 9. I've got 4 x's. I've already got 2, so I need 2 more. And I need one y. I've already got it, so we're all good. So final answer, negative 3x squared y, 9y plus 8x plus 9x squared. Okay, so you can see how this factoring is really just the reverse of the multiplying that we learned last week. And we start by finding that greatest common factor in every term, and we pull that back out. It's the reverse of that multiplying. Okay, so get to know your factoring. You can either distribute or you can box. Totally up to you. You'll get the same answer either way. Pick your favorite, learn it, love it.